Hey guys and girls, welcome back to another beautiful video on this beautiful channel on this beautiful day. How you guys and girls doing? Today we have a fun little video, and it involves our mesh class and making a primitives class, right? So a primitives class is going to be something where we have triangles, quads, planes, stuff like that. Maybe some more complex primitives that we can create and easily just put them into our mesh class. So we can have one constructor in the mesh class that you can create with a primitive, and then you can have one with a file name where you load it, and so on and so on. So this is just one step to making life a little easier, and then we don't have to use these annoying global variables. So let's just start off by making a header file, and you'll have to excuse me today, my voice is a little weird and I'm a little tired, but I'm gonna try to make this happen. So primitives.h, nothing special. So you're gonna have a class called primitive, alright, just like that, and we're going to then create a public and a private section, just like in regular classes. And the private section is gonna have a std. I'm gonna include let's go into libs, let's see. So I'm gonna include, what do I need? I need vector, string, I guess. I'll just start off with vector actually, right here. So I'll include vector, and we actually need to include vertex, and yeah, we need to include vertex. So vector and vertex. So we're gonna create a std vector of vertex and call it vertices, like that. And then we're gonna create a std vector of gluint and call it indices, like this. And gluint is of course not defined, so what we're gonna do is we're gonna put these two in here as well. Oh, whoops, am I recording? Yep. So I'm just gonna put those in there in primitives.h, and I'm gonna put it all the way up here like this. So now we have two containers that we can use, and they'll keep their sizes as well. Now what we need is we just need a primitive empty constructor, okay, and a virtual primitive destructor as well, which is empty for now, and we'll probably keep it empty as well. And then we'll have functions here, and we're gonna have a few functions, or one function actually that's called set, and this function is gonna take in variables, and it's going to let us set our containers. So const vertex pointer vertices, const unsigned number of vertices, const in gluint indices. So I'll try to make some new lines here so you can see what's going on. Const gluint pointer for the array indices, const unsigned number of indices. Okay, fine. So that's our set function, and the only thing the set function is going to do is we're going to have two for loops in here, and we're going to first go through number of vertices, and we're going to say this vertices dot pushback vertices at position I. So we're putting all of these vertices that we're sending in into our vertices vector. That's basically what we're doing. That's it. And for the second for loop is number of indices. So this indices dot pushback indices at position I. Now there we go. Indices, there we go. Holy crap. So that's good. So we're setting these two. And that's basically what we need for now. So we don't need to return anything or set anything really. All we're doing is we're just creating these, and that's fine. You know what we could do as well? We could return a vertex pointer, get vertices, and then this should get vertices inline, and just put it right there. Return this vertices.data like that. So we're getting the vertices. Same thing with get indices like that. No, GLU int get indices data. So we're sending back the data as just raw pointer, just raw arrays. Now what the hell is going on right here? Why are you crying so much, dude? Holy crap, stop crying. Okay, and then we're gonna do an inline size t. Let me just see one thing. When we're initializing the VAO, it's a const unsigned, and we're putting it in here. So we just want the size of the array, and that is a okay. You know what? We're just gonna return a const unsigned. Const. Let me make this big again. There we go. Const unsigned get number of vertices, return this vertices.size. Easy peasy. And the same thing for indices, and we should be good. Get number of indices.size. So now we're returning the actual arrays and the sizes, or the number of elements, and the set function, which is really important. So now we have a basic thing. Let's just run this. Let's run that. Everything's working. Let me just include this in here. Include primitives.h. Let me do that after vertex, and like this. Shouldn't really matter. And if I run this, we shouldn't get any problems. Okay, didn't get any problems. Main primitives.h, no problems. In main, if I create a primitive test like this, we shouldn't have any problem as well. Good. There we go. Perfect. All right, so we're good. Let's just get into coding this. So now the whole magic is going to be to create a class, quad, for example, quad and triangle and stuff like that. But let's just make a quad right now. Class quad, public, remember the public part here, public primitive. And this is going to make sure that the rest of the program knows that quad is a primitive, because it's publicly known that quad is inheriting from primitive. And then we're just gonna do this. We're gonna set a public part here, and we'll say quad, and in here what we're gonna do is we're just gonna copy paste all of this into here. Okay, just into here, and then we're gonna say this set, and it's gonna take vertices, number of vertices, indices, number of indices. So we're gonna set its basic functionality, and then we need to call the constructor as well, primitive, like this. So the quad is inheriting from primitive, and once we create the quad, it will automatically create all the data and put it into its primitives containers here, and then it will, yeah, then we can access it. So if we go into main now and we go into our mesh class here that we're creating, let's just run this one more time just to make sure that worked. Didn't really fail that much. Nope. So let's go in here, mesh class. So instead of all of these, let me change all of this into quad. Now this isn't good practice, but let me just try this. Get vertices, quad, get number of vertices. Okay. Quad dot get number of, or get indices, and quad get number of indices. And if I run this, we should have a functioning kitty cat, no problems, because all of that data is stored within our quad what do you call it, quad class. So it's all created in here. Now the reason I created primitive here is that if we go into mesh here and we say let's include primitives, and I make another init VAO function. So let me copy paste init VAO. That's going to be really annoying. Init VAO, I just copy pasted that, put it up here, minimize both of those. Okay, and instead of all this, I'm just going to do a primitive pointer primitive. All right, so that primitive coming in is going to give me a bunch of data, and that's how I'm gonna set all of this. So this, then I'm just going to use that primitive and say primitive get number of vertices multiplied by vertex, and then I'm going to say primitive get vertices. All right, so I use this primitive. I don't know which primitive I'm putting in here, but it could be anything. As long as it's a primitive, let me take its size, put all the data in here through that. And the same thing here, primitive number of indices, primitive get indices. So that way I put all that data in here with no problem. All right, no problem. And of course this needs to be primitive get number of vertices, and then primitive get number of indices. And of course we could have used that here as well. Actually, I'll change it back. This number of vertices, and we'll change this to, sorry about that, this number of indices, because they're set here. So there you go, that should be fine. So this is init VAO. Now we'll create another mesh constructor here as well. Instead of all of this, we'll just have a primitive pointer primitive like that, and then we'll use the init VAO with the primitive that we send in. So it's the exact same thing, it's just a different constructor. Alright, so here we use the other one, and here we're using the new one right here. So there you go. So init VAO, there are two different init VAOs, and we're fine. Great. So that should be good. Now if I run this code again, just to make sure we're not crashing, it's good to run your code all the time, often. So no problems yet. If any of you notice dangling pointers or something weird, please just let me know in the video below in the comment section, and I'll try to fix it. But I don't think there should be any dangling pointers, because we're as soon as primitive and quad ends, these two will be cleared and all the data will be cleared. So there shouldn't be anything left over, any memory leaks. So we should be fine, I think. Now the whole point is to go into main like this. Let's go into main and let's go to where we created this, and instead of writing all this, let's just send in quad. Okay, now let me send in address to this temporary variable quad, and let's run this. So it should use the second constructor, and we don't have any problems. Alright, no problems yet. Again, tell me if this becomes some kind of dangling weird pointer. I can't really see that right now. Doesn't seem like it, but it could be. But at least this is a way to fix it. Now you could also do it like this: quad temp quad equals quad, and then you just send in temp quad in here, and you run this. This is a way to do it as well. So another safe way to do it. No biggies, no big problems. And now we have a primitive class here. I can just minimize the primitive part, and then we can create more things. We can go ahead and create a class. Just copy paste the whole class. You have a quad. Okay, we can create a triangle with this as well. So all you have to do is you have to write triangle public primitive triangle, and then change the vertices. Alright, just change the vertices and you should be fine. So how would we change those? That's too tedious for me to do right now. I can't think. So just we could actually just remove one of these and keep the indices and try that. So that's a triangle. This is a quad. Now if I run this and I say, instead of all of this crap, I just do triangle like that, hopefully we should get a little triangle somewhere on the screen. Yep, we got a little triangle here. See that? So in that way we can create different types of beautiful primitives. And we can see that by doing GL line here, and we should be able to see the lines of this. Yeah, kind of. Okay, anyway, at least we could let's see, polygon mode, when we render this, polygon mode, GL lines. I'll check that out. There was a good way to find that. No, that wasn't it. Whatever, I'll check that out. If any of you know how to do that and remember how to do that, then just post it. I did it in the previous video, I just forgot. So, but I'll check that out. Anyway, there you go. That is the primitives class. Sorry about the long video. I'll just do quad here for now. Just put quad there for now, and we should be fine. But again, sorry for the long video. Check out the code if you want to on GitHub. I'll be updating it, and then yeah, you shouldn't have any errors. You should be fine. If you do have errors, please check the code properly, because there's a lot of code for me to debug if some of you have problems. But try to check the code carefully, every line by line. Try to have it exactly the same. A lot of you are really good at programming, and you want to make your own thing happen from the start, but then the code becomes different from mine, and it might be a little hard to find errors. But if you want, you can keep it similar to mine, so it's easier for you, and then try to customize it. But yeah, otherwise just contact me on my mail that I wrote in the description, and the GitHub link is in the description as well. So yeah, thank you all for watching. Take care, best of luck with the primitives class. Have fun, create some primitives in here, and just go ham, do your thing, and I'll see you guys and girls in the next one. Alright, bye bye.